Hello everyone, welcome back to our Engineering Mechanics Dynamics class. Today we're gonna have our lecture 6, relative motion. Last class we had our dependent motion where we derived the theories, and we saw three options of taking datums and then how it changes our sign of velocity and acceleration. So today we're going to study relative motion. As you can see in the image, there's a 3-5 plane. So each pilot should know the relative motion of the other plane so they don't crash each other. So this is one example of the relative motion application. So learning objective for today is that formulate the position, velocity, and acceleration relationship of two particles for relative motion. As we already talked about the relative motion of one plane to another when they fly together, there we can also have it in a vibrant city. If you are moving along this street, and then the people moving along this street, either in this direction, they have relative motion from this point to that point. We can apply it for that cases. And also for road or flyover bridges or road like this, we can also apply this concept. For example, if a car moving this direction and this car moving a circular direction, each of them have a relative motion from each other. So these are some examples we can apply this concept. So let's derive some relative motion concept. Relative motion. Relative motion of two particles. So if sometimes there's two particles and they're more complex, their motion, so it is sometimes easier if we have two reference points to consider their motion, so we can get the relative motion with respect to each other. So for example, if we have a basic observed point, our coordinate x, y, and z, right? So this is our origin and coordinate x, y, z. If we have one particle moving, particle, for example, B, moving in a curvilinear path, and we have another particle A, which is moving this direction. So according to our origin O, we can have the position, the absolute position of B as RB, which is a vector, and then position A, which is RA, which is also a vector. Now the problem comes when we want to see the relative motion. So if someone wants to know what is the relative position of B with respect to A, while A is also at the same time moving. In this case, it's easier if we have another axis, x prime, y prime, and z prime, So instead of using the original axes, we now having a axis that's axis coordinate system, x prime, y prime, and z prime, that is translating or moving with A. So if A is moving faster, the coordinate system x prime, y prime, z prime will move with that. So the coordinate system x prime, y prime, and z prime moves with A particle, and this origin remains the same. So how do we, coming back to our question, how do we define the relative motion, relative position, of B particle relative to A. Relative position of B with respect to A. So that is defined by the relative position, vector position, that is defined as R B respect to A. So B by A. And we know for vector formula, RB can be defined as RA plus RBA. So RB, let me have a different color. RB, this one is defined by RA plus this direction, RB by A. Simple. So RB by B by A is our target. This is also a vector. So position of B with respect to A can be found using this relationship. Once we have this position equation, we can have our velocity equation, and we can as same as VB VA plus V velocity VB over A. So this is our velocity equation. And similarly we can have our acceleration equation, same as acceleration B equals to vector acceleration A plus acceleration B over B with respect to A. So these equations are simple, and for relative motion the equations are simple. We have to realize the concept. So here our VA and VB is the absolute velocity of the particle B, and VA is the absolute velocity of particle A, and VB by A is the relative velocity of B with respect to A. And same things applies for the acceleration, where the acceleration B by A is the acceleration of B as observed by the particle A, with the reference frame, so not the original, the reference frame that we have, x prime, y prime, and z prime. So this reference frame. So now this is the concept, velocity and acceleration, position, velocity, acceleration of relative motion. This is more easier. We'll solve some problem to clarify more on this concept, and I think this is the last chapter or last section of this chapter 12. So in next we're gonna move to chapter 3 after solving some problems. Till then, thank you, and see you in next classes. Bye.